Hey guys, welcome back to Calculus Universalis. This is the final lesson of Unit 6, Integration and Accumulation of Change. Today we're going to be going over and applying everything we've learned so far to real-world problems. You'll learn how to use integrals to compute net change, how to work with accumulation functions, and how to interpret definite integrals in real-world problems. A skill that's always tested on the AP exam. Let's get into it. So our concept today is going to be net change theorem. It basically states if a quantity is changing at a rate f of t, then the net change in that quantity from t equals a to t equals b is from a to b, the integral from that distance. Think of it like this. If f of t is velocity, the integral is displacement. So if f of t is velocity, the integral is displacement. If this is acceleration, take the integral of acceleration, it's velocity. If f of t is a flow rate, c it equals a flow rate, the integral equals total volume added. So if water's flowing into a pot, it's going to be the total amount of water that was added to the pot. And then lastly, if f of t is growth rate, then the integral is going to equal total growth. How many centimeters or whatever it actually grew. So that's a quick little summary of what we're going to be going over today. Just rates and accumulation of change to find my integrals. And there's definitely going to be FRQs on this topic, 100%. So let's go over total versus net change. Total versus net. Net change includes signs, so positive or negative, or negative. The total change is the sum of absolute values, like total distance traveled. So you add everything together, and it'll become, it's always going to be positive. Now, an accumulation function will be defined as something like this. A of x equals, from a to x, f of t dt. This tells you how much what's happening has accumulated from a starting point, a, all the way to x. If you graph f of t, then a of x is the area under the curve from a to x. Let's go over our first example. So our example number 1 is going to be how much water flows into a tank from at a rate r of t equals 3t squared gallons per minute. And then how much water enters from t equals 1 to t equals 4 is the question. So in order to figure this out, say you have the integral from 1 to 4, 3t squared dt, pull the 3 out, and then this just becomes 3 times t cubed over 3 when this is evaluated from 1 to 4, which becomes 63. And this is 63 gallons. Okay, so this means that the tank gains 63 gallons over that interval, and it allows us to figure out the total amount that has happened during that time. Now let's go over example number 2. Net versus total distance. So if we have a particle moving along a line with velocity v equals t minus 3, the net distance traveled is going to, from t equals 0, t equals 6 is what we're finding, as well as total distance, net versus total. Go ahead and pause the video, see if you can do it yourself. So let's try it. So, for A, if we have our integral from 0 to 6, t minus 3 dt plus 6, 3 to 6, t minus 3 absolute value dt. When you solve this, it's going to equal 9 plus 9, which equals 18 total. So now we have our total. And then for B, sorry, this was B. Now if I'm doing A, I would find this integral from 0 to 6, t minus 3 dt equals t squared over 2 minus 3t from 0 to 6, which also is 18. So that they just happen to be the same in this case. But this isn't always true. Now let's go over our third example. So, for our third example today, if a of x equals integral from x0 to x f of t dt, and if you have a graph of f of t, what does the graph of a of x look like? The slope of a of x is a prime of x, which equals f of x. So when f of x is greater than 0, a of x increases. When f of x is less than 0, a of x decreases. And then when f of x equals 0, a of x has a horizontal tangent. So understanding this connection is essential for graph-based questions in your AP exam. Then we're going to wrap this up and see what we've learned today. So what we've learned today is the net change theorem, which is the total change in the quantity, the accumulation functions that track total change from a fixed point, how to know the difference between net change, sign included, and total change, absolute value. On the AP exam, you'll interpret integrals in context, gallons, meters, population, etc., and then connect accumulation functions to shape or graphs. Thanks for watching. Goodbye.